Hi everyone, today we are going to learn chapter 12.8, similar solid. So how do we find the volume of a similar solid? Similar solid have exactly the same shape. Now we have done similarity already in chapter 7. So pretty much we are focusing on proportion. So two solids are similar if they have the same shape and ratio. So here it is. We have done that already, like in chapter 7. No matter how you compare it, as long as you are consistent with your starting, you'll be okay. So for example, if you compare the height to the height, the next one has to be radius to radius. For example, height on the left compare height on the right, radius on the left compare to radius on the right. Next one, congruent solid have the same shape and size. That's the difference between similarity and congruent. Similarity means they have the same shape. Oh, I forgot to put up here. Same shape. Okay. But congruent is also the same size. So everything are congruent. Okay. Therefore, the volume must be equal. So that's obvious. Notice when you compare the ratio, it's equal 1 to 1. So it's 1. So let's practice. Example 1, determine if the solid are given that are similar, congruent, or neither. So the first thing we do is we compare the square period. So I start with height 1 to height 2 compared to the leg or the side 2. So height 1 is 4, height 2 is 6, leg for 1 is 8, leg for number 2 is 12. So simplify 2, 3 equal 2 over 3. Notice they are equal. So this one, the pair of its solids are similar. Okay. It's similar. Letter B, rectangular prism. So we have the height for the prism. We can call this the width for the base and this the length for the base. Regardless, you can label any way you want it. So let's begin. Height to height, 2.5 to 1.5. Then we compare 3 to 1.7. Then we compare 6.2 to 3.4. Using calculator to simplify, 1.6 equal 1.76 equal 1.8. This is not possible, so it is neither. Okay. Alright, next one, 6.2 compared to 6.2, 6.8, 6.8. This is 1 to 1, so the solid are congruent. Next one, 5 over 6 is the same as 12 over 14.4. Okay. And we want to know if they are similar. Okay. So when we cross multiply, they equal, so it is similar. Alright, next one about the surface area. Notice one thing about the surface area. So when we have a ratio, we call it scale factor like K, right? If we talk about surface area, notice we square it. Okay. And when we do the volume, it's going to be 2 to the third, 3 to the third. So the goal is, if you have a scale factor, then you could find the surface area, that means the surrounding, or the volume. Right, example 2. So we have two similar cones right here. So first we start with the small one. Draw it. Right. With the radius 10. The next one, let's say for a larger one. And we have the radius as 15. Okay. So we do the scale factor. So the scale factor is 10 over 15, which is 2 over 3. Sorry. Okay. So for the area, well, it's going to be 2 square over 3 square, which is 4 over 9. Based on this one. Alright, next one, number 2. A larger prism is 98 centimeter square. When you see a square like this, it means the area. Okay. A small prism, 18 centimeter square. Okay. We are comparing the larger one to the smaller one. So we're going to put 98 over 18, divide by 2. We got 49 over 9. Right? That is 7 square over 3 square. Therefore, the scale is 7 to 3. Which is the ratio? Alright, the last example, number 3. So we compare the height to 10, because we don't know this height, but we know the other one is 10. Then we compare the volume to 70 pi over 640 pi. This we can simplify equal h over 10, 27 over 64. Okay. So h over 10 equal 3 to the third power over 4 to the third power, right? Because we have to write as a scale factor. Once we have this, then we just compare it. Okay. Cross multiply for h equal 30, so the height is 7.5 inches. Because if we compare the height to the other height, we don't know, but we know the scale factor has to be 3 over 4. So I hope this is helpful. Please send me an email if you have any question or concern. Thank you.